Welcome to Tempest Industries' official YouTube channel. Today we're going to talk about work holding solutions. Our CNC machine uses what's called a vacuum pump system and a spoil board system to hold our work in place. This is a vacuum table. It covers the whole thing. We've got our spoil board on top of it so you can't see the whole thing. But what it does is it uses a vacuum pump that's basically like a giant vacuum cleaner to draw air through these holes in the table, which will create a section on the table which will hold big sheets of material like this on our table. So some of the pros of vacuum table, well, the big pro is it's a great method of holding down large sheets. And our CNC machine, it's a CNC router, is optimized for sheet goods. So anything with a large surface area, because it has a large surface area, when air is drawn across that entire surface area, it creates great suction along it and can hold the entire area rather than, toe clamping it or whatever along the outside of your material that you're trying to hold down. You have the ability to hold down the entire area at once. So it's fantastic for sheet goods. It's not great for things that are irregular shaped. If you have anything that has any grooves in it or anything that isn't perfectly flat, the vacuum table won't hold that down at all. So one of the cons of the vacuum table, other than irregular surfaced materials, is debris. So a vacuum table, because it uses a pump which is mechanical, as soon as you introduce any debris into it, whether it's dust or chips or whatever, it's going to kind of screw up your pump, and that's expensive and costs a lot of money to replace, and it's not fun when it goes down. So we use something that's called a spoil board, which this is a spoil board. A spoil board is a sacrificial piece of material that is porous. In this case, we use MDF that we buy at our local hardware store. We buy it at our local hardware store because it tends to be lower quality, which is fantastic because it's more porous, meaning it allows more air to be drawn through it. And that's crucial because that's what will continue to allow our materials to be able to hold down to our vacuum table. So we put this material on top, it allows air to be drawn through it, and it will act as a buffer to keep debris from entering into our vacuum pump and destroying our vacuum pump, meaning that we can continue to get years of service and not have to deal with costly maintenance and replacing stuff because we were just too lazy to, figure something out. So once we buy our material, we can't just throw it on top of our machine and call it a day. We have to actually do what's called flying our material, which means we go across the entire surface and we take just a thin layer of material off of it. And we do this for a couple of reasons. So the first reason is MDF typically has a coating on the surface of it that will keep it from, it just makes it smoother, which is great for if you're using it as a finished product, but it also hinders the airflow a little bit. Again, we're using low quality, so it doesn't hinder it that much, but we take that surface off of it so we can open up the pores so we can allow even more airflow through our material. The second reason is for something called tram. So we Googled it, so we got this right. But tram, in regards to CNC, is tramming a CNC router is defined as squaring up the Z-axis motor spindle so that it's perpendicular to a level router table in two directions, the X and Y axis. Okay, so what that means is you want to make sure tram is making sure that your spindle and your bits are perfectly perpendicular to your table surface. And that's crucial for cutting your parts because you don't want any variation in your Z-axis. When you are cutting along your X and Y axis, you want to make sure your Z-axis stays exactly where you want it in relation to the depths of your cuts. So that's crucial. For an accuracy standpoint, for a repeatability standpoint, everything, that's crucial. So because we're working with a large surface area on a CNC router table, there tends to be variations within our tabletop surface. And so when we throw our spoil board on top of it, we fly it every time we replace our spoil board in order to make sure that our tram, our router, is perfectly perpendicular to our surface by taking our bit and going over the entire surface so that we know that everything is perfectly perpendicular. When we throw new material on top of it, we know that it is also now perpendicular with our router head. And when we cut, we can be sure that what we're cutting is to the proper depth, and then we're not going to have any issues with that. So that's what spoil board is, that's what a vacuum table is, and that's how we deal with those issues.